Hello everyone, thank you for joining me today. I am Raity Vojdani and my presentation is about exceptions in C Sharp. We will explore what exceptions are, how to handle them effectively, and the concept of checked and unchecked exceptions in C Sharp. By the end, you will have a solid understanding of exception handling and how to use it in your programs. So let's begin. Today, we are going to explore the essential aspects of exception handling in C Sharp. First, we will start with what are exceptions. Then we will dive into the exception hierarchy. And next, we will discuss the exception lifecycle, covering the steps involved when an exception is thrown and handled. And after that, we will review the syntax of exception handling, including try-catch blocks. And moving forward, we will learn about the finally block, which ensures a specific code execution regardless of an exception. We will also explore throwing exceptions to understand how to manually raise them. To give more context, we will look at commonly thrown exceptions in C Sharp. Lastly, we will cover checked and unchecked exceptions, discussing how they differ and their implications in coding. So let's get started. Okay, what are exceptions? Exceptions are errors that occur during the execution of a program. Instead of crashing the program, exceptions allow us to gracefully handle these errors and ensure the program can recover or inform the user. All exceptions in C Sharp are derived from the system exception class, which is part of the base class library. Okay, let's talk about exception hierarchy. C Sharp has a structured hierarchy for exceptions. At the top, we have the system exception class. Below it, there are two main categories. System exception, which includes runtime errors like division by zero, and system application exception, used for application-specific errors. And some common exceptions include argument null exception, index out of range exception, and divide by zero exception. Okay, let's talk about exception lifecycle. Handling exceptions in C Sharp involve three main steps. First, we throw an exception when an error occurs. Second, we catch the exception using a try-catch block. And if we don't catch it, the exception moves up the call stack until it's handled or causes the program to crash. It's important to understand this flow for effective error handling. To handle exceptions, we use a try-catch block. The try block contains the code that might throw an exception, and the catch block handles it. For example, if you try to divide a number by zero, an exception is thrown, and the catch block can log the error or notify the user. Let's talk about finally block. Sometimes we need to clean up resources regardless of whether an exception occurs. And this is where the finally block comes in. It always executes even if an exception is thrown. And a common use case is closing database connection or freeing up resources or other examples. Throwing exceptions. We can manually throw exceptions using the throw keyword. This is useful when we need to indicate an error in custom logic. For example, if a required parameter is null, we can throw an argument a null exception. But remember, exceptions should only be thrown for exceptional cases and not for normal flow control. Commonly thrown exceptions. Here are some exceptions you will encounter often. For example, null reference exception occurs when we try to use an object that is null. Argument out of range exception is thrown when a value is outside the expected range. And a check about checked and unchecked exceptions. In languages like Java, checked exceptions require explicit handling by the programmer. But C# doesn't use this approach. Instead, C# focuses on unchecked exceptions, which are runtime errors. Let's talk about custom exceptions. Sometimes the standard exceptions, like null reference exception or index out of range exception, aren't enough to explain what went wrong in your program. And that's where custom exceptions come in. Custom exceptions are like creating your own special error messages that make more sense for your program. And you can define what kind of problem occurred and give extra details. So, why do we need custom exceptions? Let's say you are creating a library system and a user tries to borrow a book that's already checked out. There isn't a built-in exception for this specific problem, but you can create your own exception, for example, like a book not available exception or something else. And it makes the error easy to understand for anyone who reads the code. And think of a vending machine. If you select a drink that's out of stock, instead of just saying, for example, error, it could show a custom message. For example, this drink is unavailable. That's like a custom exception. It tells you exactly what's wrong in a clear way. And custom exceptions help make your code more specific and easier to understand. They're like writing notes for someone else or even your future self about what went wrong and why. And there are times when built-in exceptions aren't descriptive enough, and we can create custom exceptions by subclassing the exception class. For example, we might create a custom exception for a specific business rule. This makes our error message more meaningful. Let's talk about exception filters. In C#6 and later, we can use exception filters to handle errors more specifically. For instance, we can catch an exception only if its message contains a specific text. This avoids unnecessary catches and keeps the code cleaner. About performance consideration, throwing and catching exceptions is expensive in terms of performance. Where possible, validate input to prevent exceptions. For example, instead of catching a null reference exception, check if the object is null before using it. Error codes versus exceptions. Error codes were commonly used before exceptions became popular. While they work, they clutter the code with checks. Exceptions, on the other hand, provide a cleaner way to handle errors. In C Sharp, we prefer exceptions for their clarity and efficiency. Let's avoid these common mistakes. First, don't swallow exceptions by leaving catch blocks empty. And always log or handle errors appropriately. And second, don't use exceptions for normal control flow like breaking out of a loop. And the third, avoid catching generic exceptions unless absolutely necessary. Let's talk about debugging exceptions. Visual Studio provides excellent tools for debugging exceptions. Use exception setting to break on throw exceptions. When debugging, always inspect the inner exception property for more details about nested errors. Okay, let's talk about real world example. Let's look at a practical example. Here we try to read a file. If the file doesn't exist, a file not found exception is thrown. And the catch block logs the error and informs the user. This ensures the program doesn't crash and handles the error gracefully. Let's look at another real-world example. Imagine you're building an online shopping system where customers can buy items. For this, we might have a method to process payments. But during payment processing, many things can go wrong. For example, the credit card is expired, or there are not enough funds in the account, or the payment gateway is down. If something like this happens, instead of crashing the program, we use exceptions. And think of this like ordering pizza online. If you enter the wrong address, the system will give you a warning. And if the pizza place runs out of ingredients, it will notify you. But no matter what happens, the system will end the process properly, and maybe by thanking you for your attempt to order, I mean the finally block. And this helps to handle errors clearly and make sure the program doesn't fail unexpectedly. Okay, to summarize, exceptions are critical for robust error handling. Use specific exceptions and follow best practices to write maintainable and error-resistant code. And to wrap things up, let's quickly review what we learned about exceptions. The first one, what are exceptions? Exceptions are problems that stop the normal flow of your program, like dividing by zero or trying to access something that doesn't exist. And how do we handle them? We use try, catch, and finally blocks to catch these problems and handle them properly. So the program doesn't crash. And the third question was about why is this important? Imagine using an app that crashes every time there is a small problem. You would stop using it, right? And handling exceptions make programs reliable and user friendly. Think of driving a car. If you run out of fuel, I mean the error, the car doesn't just explode it. the crash. And instead, it warns you with a fuel light, and this part is like exception handling. And you then pull over safely and refuel. This part is like fix the problem. And that's exactly what exception handling does for programs. It lets them recover or stop safely. Always plan for the unexpected in your code. Think about what could go wrong and handle it using exceptions. Because this makes your programs more professional and easier for others to trust and use. Okay, that was my presentation. Thank you for your attention. I hope this presentation gave you a clear understanding of exceptions in C# and have a great day. Goodbye all.